Now let's practice counting back in thousandths. So to start, we have 0.537, so we can show that with 5/10ths, 300ths and 7,000ths. If we're counting back in thousandths, we then have 0.536, then 0.535. What are the next 7 numbers in this sequence? Well, if we show them, we can see that counting back in thousandths is similar to counting back in ones. The only value that we need to change is 0.530, because we don't usually write zeros on the end of decimal numbers. So 0.530 can just be written as 0.53, because all the 0 on the end tells us is that we don't have any extra thousandths, but 0.53 tells us this as well. It's also important to notice that 0.529 is smaller than 0.53. In fact, it's 1,000th smaller, because we're counting back in thousandths. So let's show the counting using place value counters. We start with 5/10ths, 300ths and 7,000ths, so that's 0.537. We can keep on subtracting thousandths, but when we get to 0.53, so 5/10ths and 300ths, we need to exchange one of our hundredths for 10 thousandths, so that we can continue subtracting thousandths until we get to our last value, 0.528, so that's 5/10ths, 200ths and 8 thousandths. Now we start with 0.905, so that's 9/10ths, no hundredths and 5 thousandths. If we count back in thousandths, we have 0.904, 0.903, and then you can see how we can complete the sequence. So counting back in thousandths is similar to counting back in ones, but we get 0.900, and we don't need to write zeros on the end of whole numbers, because 0.9 is the same as 0.900. So we can see what we're doing is taking away thousandths. But then, when we get to 0.9, so 9/10ths, we need to exchange one of our tenths for 10 hundredths. But because we want to count back in thousandths, we can take one of our hundredths and exchange it for 10 thousandths. So now we can continue counting back in thousandths, so 0.899 is 1,000th less than 0.9, and we can continue subtracting thousandths until we get to 0.896, so that's 8/10ths, 9 hundredths and 6 thousandths. Now 3.507, 3.506, 3.505. What are the following numbers in this sequence? Well, we're counting back in thousandths, and that's similar to counting back in ones, except that we get 3.500, and we don't write zeros on the end of decimals, because 3.500 is the same as 3.5. So notice the pattern goes 3.501. If we take away 1,000th, we get 3.5. Then, if we take away 1,000th from that, we get 3.499. And we can use place value counters to explain this. So we start with 3.507, so that's 3 ones, 5/10ths, no hundredths, and 7 thousandths. If we're counting back in thousandths, we're taking away 1,000th each time. So here we've got 3 ones and 5/10ths, so that's 3.5. What we can do is take one of our tenths and exchange it for 10 hundredths. But we're taking away 1,000th at a time. So what we need to do now is take one of our hundredths and exchange it for 10 thousandths. So now that we've exchanged and exchanged again, we can take away one of our thousandth, and we can see that that's 3.499, because we have 3 ones, 4 tenths, 9 hundredths and 9 thousandths. So we just need to take away one more thousandth to leave us with 3.498. Finally, we start with 1.005, so that's 1 whole, no tenths, no hundredths and 5 thousandths, because the third digit after the decimal point tells us how many thousandths we have. Then, if we're counting back in thousandths, we get 1.004, 1.003, and what 7 numbers come next? Well, we can show them here, and we can see counting back in thousandths is similar to counting back in ones. But you'll notice we have 1.000. Now if we have a decimal point and then zeros on the end of a number, we have a whole number. All the 0.000 tells us is that we don't have any tenths, hundredths or thousandths, but just writing the whole number 1 tells us this as well. So again, let's use place value counters so that we can see what we did here. We're counting back in thousandths, so taking away one of our thousandths counters each time. But now, when we have 1 whole, in order to subtract thousandths, we first need to exchange that 1 whole for 10 tenths, because 10 tenths is the same as 1 whole. Then we can take one of our tenths and exchange it for 10 hundredths, because 10 hundredths is the same as 1 tenth. And finally, we can exchange again, taking one of our hundredths and exchanging that counter for 10 thousandths counters. So now we can keep on taking away thousandths until we get to 0.996, so that's 9 tenths, 9 hundredths and 6 thousandths. Thank you so much for watching. I really hope that was helpful. If you're a teacher or a parent, then please subscribe or go to keystage2maths.com to download resources for this lesson and many more. That's all for now. I'll see you in the next video.